For today's lesson, we will be comparing two quantities, which means we'll be working with ratios. And we have a couple standards that we will be working with, and they're listed here, 6RP1 and 6RP3D are our two standards that we'll be working with today. When writing a ratio, you need to have two skills. One is one of your first skills that you learned, and that's counting, and the other is reading. So here we have two sets of blocks. We have some orange blocks and we have some green blocks, and we want to compare these two quantities using a ratio. Well, if I were to ask you to compare the orange blocks to the green blocks, there are 7 orange blocks being compared to the 4 green blocks. That's one way you can write your ratios, by putting the number of orange blocks first, put the word 2, and the number of green blocks second. Another way you can write your ratio is, again, we're putting the number of orange blocks first because we want orange to green. Instead of the word 2, we use a colon, and then we put the number of green blocks second. And then the third way to write the ratio is in the form of a fraction. So I want orange blocks first, green blocks second. So it'd be 7 to 4. If I had asked you to write the number of green blocks to orange blocks, our ratios would be flipped around and it would read 4 to 7. When two quantities such as the lengths of two rods have the same units, you can write a ratio without units to compare the quantities. So again, if I was asking you to write the ratio of the red rod to the blue rod, since red was listed first, we put that number first. Blue was second, so we would have 5 to 9, or you replace the 2 with a colon, 5 to 9, or write it in the form of a fraction. If it was blue to red, it would be 9 to 5. All right, as our young lady tells us, this will come into play a lot later in our chapter, in our work with ratios, but the ratio does not give the actual number of cubes necessarily. So if we were talking about bags of cubes, we could say that there were 7 bags and 7 bags of orange, 4 bags of green. So, and we're assuming that each bag has an equal number of cubes. So we could actually have, 700 orange cubes. So that's something to remember, is that the ratio does not always tell you the actual number of items. So for our examples here, we want the ratio of the number of DVDs, the number of DVD sleeves. Well, since DVDs is listed first, we count that. We have 3. And then DVD sleeves is listed second, so we count that. And we get 5. So 3 to 5 is our ratio of DVD to DVD sleeves. Mrs. Clark buys 4 bags of apples and 7 bags of oranges. Each bag has an equal number of fruit. So with the ratio of number of apples to number of oranges, so we have 4 bags of apples, so it's 4, and we have 7 bags of oranges, so our ratio is 4 to 7. Alexis has a cat that weighs 12 pounds and a dog that weighs 25 pounds. So we want the ratio of the weight of the dog to the weight of the cat. Well, since the weight of the dog is listed first, that number goes first. So the weight of the dog is 25, and the weight of the cat is 12. Excuse me. If you want to use a ratio to compare two quantities at different units, such as meters and centimeters, you must first express the quantities using the same unit. So if we have 7 centimeters compared to 3 meters, it's first important to get those into the same unit of measurement. And you can see our young man over here tells us that 1 meter is equal to 100 centimeters. So if 1 meter equals 100 centimeters, well, 3 meters would equal 300 centimeters. So we would have 7 centimeters compared to 300 centimeters, which would give us a ratio of 7 to 300. A couple other conversions that would be important to know is knowing that 1 meter is also 1,000 millimeters. And with these, you can take out the meters and put in any of your other metric conversions like liters or grams. 1 centimeter or 1 centigram or 1 centiliter, which isn't really a thing that I've heard of, but we'll throw it in there anyway, is equal to 10 millimeters or milligrams or milliliters. And 1 kilometer or 1 kiloliter or 1 kilogram is equal to 1,000 meters, grams, or liters. So knowing those conversions will come in pretty handy. If you have 2 measurements, but they're not measuring the same thing, you cannot write a ratio. So if you have 3 centimeters, which measures distance, and 7 kilograms, which measures weight or mass, you cannot write that as a ratio. So for these first 3 here, we're going to determine whether or not we can express that as a ratio. Well, number 1's pretty easy since they're both measuring kilograms. Yeah, you can write that as a ratio. Number 2, 72 feet and 2 yards. Yes, we can write that as a ratio because they're both measuring distance, they're both measuring the length of an item. Number 3, we have 3 ounces and 30 inches. Well, ounces measures weight, inches measures distance. So no, we cannot write that as a ratio. Questions 4, 5, and 6, we're going to do some converting. So we have 13 centimeters to 2 meters. Well, I know that 1 meter is equal to 100 centimeters. So I have 2 meters. So that's equal to 200 centimeters. So my ratio is 13 to 200. For number 5 here, I have 5 kilograms to 13 grams. So I know that 1 kilogram is equal to 1,000 grams. So my 5 kilograms would be equal to 5,000 grams. So my ratio would be 5,000 to 13. And finally, number 6 here, I have 9 milliliters to 7 liters. Well, I know that 1 liter is equal to 1,000 milliliters. So 7 liters would be equal to 7,000 milliliters. So my ratio is 9 to 7,000. It's going to be extremely important that you answer the question that you're being asked, which means you do need to read things carefully. There might be a little bit of extra work that you have to do. So there were 55 adults and 32 children at a party. So we want to find the ratio of the number of adults to the number of children at the party. So again, we're going to find the word to. Since the number of adults is listed first, we put the number of adults first. Number of children is listed second, so we put the number of children second. And so our ratio is 55 to 32. For part B, we want to find the ratio of the number of children to the total number of people at the party. So again, we find the word to. The number of children is listed first. Well, there are 32 children at the party. We want to find the total number of people at the party. So to find the total number of people, we add the children and the adults, and we get 87 people at the party. So Miguel keeps 17 angelfish and 24 guppies. So we want to find the ratio of the number of angelfish to the number of guppies. Well, there are 17 angelfish. There are 24 guppies. So our ratio is 17 to 24. Part B, we want to find the ratio of the number of guppies to the total number of fish. Well, there are 24 guppies. We're comparing that to the total number of fish. Well, the total number of fish would be 41 because we take 24 plus 17 to get the total number of fish. Logan has a string 72 centimeters long. He cuts it into two pieces. The length of the shorter piece is 31 centimeters. We want the ratio of the length of the longer piece to the total. Well, if the string was 72 centimeters and he cuts into two pieces and the shorter piece is 31, that means the longer piece is 41. And we're comparing that to the total length, so it'd be 41 to 72. Number 3, the total amount of money Paige and Layla saved in a month was $45. Paige saved $13. So the amount of money that Layla saved would have been $32 because 32 plus 13 is 45. So we want to find the ratio of the total amount of money Paige and Layla saved. Well, the total amount of money was 45. And we're comparing that to the amount of money Layla saved, which is 32. So 45 to 32. The number of red parrots is 7/8 of the number of green parrots, which means for every 7 red parrots, there are 8 green parrots. So it's not only a fraction, it is also a ratio. So the ratio of the number of red parrots to the number of green parrots is 7 to 8. And one thing to be aware of, it's 7 to 8 because it says it's 7/8 of the number of green parrots. If the question said the number of red parrots is 7/8 of the total number of parrots, then our ratio would not be 7 to 8, but it would be 7 to 1 because of how it's worded. So you do have to read things very carefully with ratios. So the ratio of the number of green parrots to the total number of parrots is 8 to 15. For every 9 female teachers in a school, there are 5 male teachers. So what is the ratio of the number of male teachers? Well, that's 5 to the total number of teachers, and that total is 14. What fraction of the teachers are females? Well, there are 9 female teachers, 14 total. So essentially part A and B, they're actually asking the same question because they're comparing the number of one gender to the total number of teachers. You just write them a little bit differently. All right. And for our final examples here, there is a pattern that exists, and it's very important that you follow the pattern. And it starts with the question. How many? Well, we don't know how many. And when we don't know how many, we always use a variable. So we're going to pick a variable. Times tells us to multiply. So we're going to multiply. The height of the horse. Well, we come up to our bar model, and our horse has 3 blocks. So the height of the horse is 3. The word is tells us to use our equal sign. Height of the giraffe. The height of the giraffe is 6. So now we have an algebraic equation. Since we're multiplying by 3 to isolate the variable, we have to divide both sides by 3. 6 divided by 3 is 2, so n equals 2. So again, we want to make sure that we're following the pattern. So how many, we don't know, so we use a variable, times, tells us to multiply, height of the giraffe, 6, is our equal sign, height of the horse is 3. So if we don't follow our steps here, we could come up with the wrong answer and say that k equals 2, which would not be a correct answer. Because if we look back at the other one, we have to divide both sides here by 6. Well, we have 3 divided by 6. Well, 3 divided by 6 is a fraction, and 3 over 6 can be simplified to 1/2. So if Allie spent $12 and Jada spent $36, so again, how many? We don't know. Times, we multiply. The amount of money Allie spent is 12, is our equal sign. The amount of money Jada spent is 36. Divide both sides by 12. P equals 3. How many? We don't know. Times, we multiply. Amount of money Jada spent, 36, is equals the amount of money Allie spent is 12. Divide both sides by 36. Till 36 is a fraction, we simplify our fraction down to 1/3. That is all for today's lesson. I hope this helps.